It's time for Security Now. Steve Gibson is here. There's a big flaw in the world's most popular email server, and it's been there for a long time. We'll talk about a new attack on Wi-Fi and passwords that you don't have to worry about. Whew. And why is there no Nobel Prize for mathematics? Steve Gibson, and then a whole lot more coming up next on Security Now.
Podcasts you love.
From people you trust.
This is TWiT.
This is Security Now with Steve Gibson, episode 942, recorded Tuesday, October 3rd, 2023. Encrypting ClientHello. Security Now is brought to you by Thinkst Canary. Canary tokens are a quick, painless way to help defenders discover they've been breached by having attackers announce themselves. For 10% off and a 60-day money-back guarantee, go to canary.tools/twit, enter the code TWIT in the How Did You Hear About Us box. And by ExpressVPN. Make sure your online activity and data is protected with the best VPN money can buy. Visit expressvpn.com/securitynow right now and get 3 extra months free when you buy a 1-year package. And by Collide. Collide is a device trust solution for companies with Okta. Collide ensures if a device isn't trusted and secure, it can't log into your cloud apps. Visit KOLIDE, collide.com/securitynow to book an on-demand demo today. It's time for Security Now, the show featuring the star of the TWiT network, Mr. Steve Gibson. And I say that, Steve. Hello, Steve.
Hello.
I say that because I was in Green Bay, Wisconsin, as you know, last week. Thank you, Ant, for filling in. And Friday, we had a meetup, about 50 fans. Universally said, thank God Steve extended his show number beyond $9.99. They were worried. So they're very relieved. Thank you on behalf of all of Wisconsin.
I'm glad I did, and I'm glad Michael got to see his Packers.
Oh, my. It was a terrible game, but that's okay. We had fun. And if you're an NFL fan, going to Lambeau Field is really kind of going to Mecca. So it was great for all of us. We had a great time. Yeah.
So, Leo, if you've been short of sleep lately, once we get into the main topic today, that might be a good time.
Oh, dear. No. Why do you say that, Steve?
We're going to talk about, as I was writing this up, I was thinking, oh, wow. I mean, this is really interesting to a subset of our listeners. The idea.
Steve, no, you're not supposed to say that. You're supposed to say, oh, you're going to want to stay tuned to find out about encrypting ClientHello.
It's crucial that we talk about it. But one of the things that I've liked best about the internet is that it was designed in the beginning by some really smart people who basically kept it simple. You know, I mean, even when we tackled, okay, how does it work? Like, how does packet routing work? Once we explained that, a packet has an address. And when it goes to a router, the router looks at it and goes, oh, well, then that means I need to send it down this wire, or I need to send it down that wire. And then it goes to another router, and that router does the same thing.
Yeah.
I got to send it down that wire, or I'm going to send it down that wire.
Yeah.
Yes, it was simple. And even as we've added more things, it's basically stayed simple. Now that changes.
Uh-oh.
It turns out that there has always been a privacy leak, even with HTTPS and TLS and all of our authentication and all of our encryption. There's still been a problem, and here's where the story turns sad, because to fix it, to really fix it, we lost simplicity. It stopped being clean in a way that it has always been. So we're going to talk about this today, and we have to, because it's going to be the way the world works in the future. But Oh, it's not simple. We lost that elegance. But we're going to get to that. We're going to answer a bunch of questions first because our listeners have said we like the question format. So, just how irresponsible have the developers of the most popular email server on Earth been shown to be?
Oh, boy.
Wow. Bad. What nefarious intent has infiltrated AI dialogue? Windows 11 now supports Passkeys, but what does that mean for the browsers and the add-ons that already do? The tech press is warning about a new password stealing attack against users of public Wi-Fi. Does it work? Are they right? And just how worried should we be? Why isn't there a Nobel Prize for math? Was it due to a jealous husband?
What?
Oh, yeah. Is our email address the only way for the LastPass vault decryptors to target their victims? Is there any way to keep AI models from training on our own website's content? And I'm not sure why you would want to, but okay. Does anyone have a shortcut for learning SyncThing? Is it best not to keep lithium-ion batteries fully charged? Where's a clever place to keep encrypted data offline? And what happens to old mathematicians? After we answer those questions and more, we're going to look at the hoops the Internet's designers have had to go through to keep eavesdroppers from learning which sites we visit. Welcome to Security Now podcast number 942 for October 3rd, 2023. Buckle up.
And prepare to be bored, apparently, a little later on. But you know what? I know
No. For the right people, this is one of those where they're going to be glad the propeller on their beanie is as large as it is because it needs to grab a lot of air.
So this is a challenge. That's good. Here's a chance for you to stretch your brain a little bit.
And, of course, we do have a good picture.
We do. But before we do all of that, let me show you this. This little thing looks like a USB hard drive maybe, something like that. It is not. This is the best little security device anybody could imagine. Everybody should have. This is a Thinkst Canary, a honeypot sitting on our network. You see the Ethernet wire there and a power wire. That's all it's connected to. But boy, it is not to a bad guy, obviously scary or risky. It looks valuable. This looks special. This is what the bad guy's been looking for. But the minute a bad guy hits it, you will get an alert. Only the alerts that matter, but when you get those alerts from your Thinkst Canary, you know someone's in your network. This is the problem. We all have, I would hope, strong perimeter defenses, but as we've learned time and time again, people get in anyway with social engineering, finding flaws in software. There's a myriad bunch of holes here. And really, you're not fully protected unless you have some sort of alert system, warning system that tells you if someone's gotten in. And that's what this is for. Now, I'm showing you the hardware canary, but there's also VM canaries, and there's canary tokens, which I love. In fact, I think we talked about Thinkst Canary tokens years ago when they first came out, more than a decade ago. If you have a canary, you can generate documents, PDF files, Word documents, spreadsheets, whatever. You can generate documents that look, for all intents and purposes, like real documents. You might name them something like payroll or employee social security. No, don't make it too obvious. Just employee info. That would be good. But they aren't regular documents. They're tokens that phone home the minute somebody tries to open them. They connect right up to the canary, and you get an alert that says, boom, somebody is snooping around. There's little room for doubt when you get a canary alert. If someone nefarious has browsed a file share, opened a sensitive-looking document on your canary, or tried to log in, this my canary, canaries can be anything. They can look like a Windows server, Linux server. In this case, mine's a Synology NAS. And it is a dead ringer for a Synology NAS, down to the MAC address, down to the UI. It looks just like DSM-7. An attacker is not going to know the difference, but when they try to log in, you get a little hello. And you'll get information too, because you'll see the email and password they tried to use, which is often very, very valuable. You can have the alerts any way you want. Of course, they support syslog, but also webhooks. There's an API. You can get them on Slack, text message, email. You can get a phone call if you want. Thinkst has put a huge amount of effort into making sure they don't introduce new vulnerabilities to a customer network. These canaries are bulletproof. And if a bird can let off just one warning before it's owned, it's lived up to its namesake, the canary in the coal mine. It's earned its keep. So you'll be glad to know. The Thinkst, we've not talked about this before, but there was some interest. So let's talk about it. The Thinkst Canary founding team has a background in offense. They've trained governments. They've trained in corporations how to attack, right? But when developing these, they prioritize defensive thinking. And actually, it's probably the best people to do that, right? People who know how to get in or know where to look. So they designed these with security in mind. The Canary team is uber conscious of your trust in their product, so they take lots of measures to ensure the devices are not going to add risk to your network. They're designed to be secure. They use memory-safe languages. They use sandboxing. The architecture ensures no critical network secrets are stored on this canary. To maintain security, canaries are not allowed to be dual-homed or even to span VLANs, which would give attackers a chance to jump across networks. It sits on the one network only. They've really done the job. I think you will approve once you look more deeply into this. Customers have the option to break the back-end authentication link to prevent Thinkst staff from accessing the console. Additionally, they do third-party assessments. In fact, the third-party assessments universally commend the design of the platform and the software stack implemented by Thinkst. I'm not surprised. These guys are smart. So hardware like this, VM or cloud-based canaries, they're deployed and loved on all 7 continents. In fact, you can see the love if you go to canary.tools/love. This is genuine customer tweets or messages about this device. Some of the biggest names in security have something to say. Canary.tools/love. And if you want to get one, please use our address, canary.tools/twit, okay? And use the code TWIT in the How Did You Hear About Us box to save 10% off for life, forever, for as long as you're a customer. Give you an idea of the pricing, 5 canaries, which for a small business like ours is just right. Bigger banks, casino back ends, those kinds of operations might need many, many more. But 5 canaries, $7,500 a year, and that includes maintenance, your own hosted console, all the upgrades, all the support. If you sit on it, if you break it, they'll give you a new one for free. So it's, that's a good deal. It adds incomparable value, but I got to tell you, they're so confident that they offer a 2-month full refund, money-back guarantee. If for any reason you don't like this thing, maybe you want to, attack it, see if it's as secure as they say it is. That's fine. You got 2 months to break it and get your money back. I have to tell you, though, in all the years that we have been doing ads for this product, their refund guarantee has never been claimed, which is another way of knowing these things are great. Once you get them in your business, you'll wonder how you survived without them. Canary.tools/twit, the offer code TWIT in the How Did You Hear About Us box for 10% off for life. Very good. Very cool stuff. Thinkst Canaries at canary.tools/twit. I am ready for a picture.
So anyway, this is clever. Some family has 3 cats, and they thought, hey, that's nice. We'll get this cat food holder that's got 3 bowls.
We have this exact product.
No
down
kidding.
To the ears. Yes.
Even with the kitty ears showing.
Even with the ears and those bowls. I know this product.
So anyway, this is a 2-frame picture. If we on the first frame, we see the 3 bowls, sort of in a nice stand.
Each cat gets their own, yeah.
Has its own, exactly, has its own food. And the caption here is, developer makes a simple, intuitive UI. And then in the second frame, we see what the cats have done with this. The white cat is standing behind the bowl on the left, but is eating from the bowl on the far right.
This is so real.
The black, yeah, exactly. The black cat is not dissuaded by this. It stuck its head underneath the white cat's tail, and it's decided to eat from the bowl on the left, even though it's standing in front of the bowl on the right. And the tabby is in the middle with its head under both of the cats, the black and the white cats, which are crossed over to the opposing side bowls, and it's eating from the middle. So essentially, it's the only one that understood the user interface. The other two, not so much. And the result is just sort of not
Typical.
what the designers intended.
They're
or
cats.
planned.
Come on, man. They're cats.
So, and this, of course, the second frame, whereas the first frame was labeled "Developer makes a simple, intuitive UI," the second frame is labeled "Users." Yeah, exactly. Okay, so here's the question: what can make things worse for a very widely deployed public-facing internet server, which is like server family, which is found to be vulnerable to remote code execution by anyone, meaning any unauthenticated connection, thanks to classic buffer overruns? What can make it worse? Well, how about that server's publisher ignoring the ZDI, the zero-day initiative's attempts at responsible disclosure of these problems to them for over a year?
Oh, boy. Yikes.
Ooh. The server in question is the most popular server on the internet. It's the open source Exim, EXIM.
A lot of people use this.
Yes.
Yeah.
3.5 million people at last count by Shodan.
To reassure people, who our sponsor Fastmail uses Cyrus, not Exim, but
Yep.
a lot of others do.
A lot of others. So 3.5 million currently exposed online based on a recent Shodan search, most of them in the U.S. I think it's 1.9 million. Some were in the United States, followed by Russia and Germany in second and third places. Back in June of 2022, ZDI reached out to Exim to inform them of multiple known highly critical problems that had been found by an anonymous researcher. And we're talking about highly critical as in a CVS score of 9.8, which, as we know, that's difficult to get. On June 14th of last year, 2022, after asking for and receiving a contact information for the right person to speak to with Exim, ZDI reported the trouble. So that was June 14th, 2022. Then ZDI waited and waited and waited until a little more than 10 months had passed. On April 25th of this year, they asked for an update. Exim said, huh? and asked ZDI to please resend the reports. On May 10th, ZDI resent the vulnerability reports. Then another 4 months went by until finally last Monday, the 25th of September, ZDI again asked for an update while also informing Exim that, we've been patient enough. We're going to publish the entire case as a 0-day advisory in 2 days, which was last Wednesday. And ZDI has written in their disclosure, they said, quote, given the nature of the vulnerability, the only salient mitigation strategy is to restrict interaction with the application, which is, a very political way of saying unplug the server now. 2 days later, last Friday, Bleeping Computers headline read, millions of Exim mail servers exposed to 0-day remote code execution attacks. Bleeping Computer wrote, a critical zero-day vulnerability in all versions of Exim mail transfer agent, MTA software, can let unauthenticated attackers gain remote code execution on internet-exposed servers. Yes, that's all 3.5 million of them. They said found by an anonymous security researcher and disclosed through Trend Micro's zero-day initiative, the security flaw is due to an out-of-bounds write weakness found in the SMTP service. While this type of issue can lead to software crashes or corruption of data following successful exploitation, it can also be abused by attackers for code or command execution on vulnerable servers. ZDI Security Advisory published on Wednesday, meaning 2 days before last Friday when Bleeping Computer published this, explains, quote, the specific flaw exists within the SMTP service, which listens on TCP port 25 by default. The issue results from the lack of proper validation of user-supplied data, which can result in a write past the end of a buffer. An attacker can leverage this vulnerability to execute code in the context of the service account, unquote. And Bleeping Computer continues, while ZDI reported the vulnerability to the Exim team in June of 2022 and resent info on the flaw at the vendor's request in May of 2023, the developers failed to provide an update on their patch progress. As a result, ZDI published an advisory on September 27th with details on the 0-day and a full timeline of all exchanges with the Exim team. Okay, so following ZDI's actions, there was some back and forth on the open source security mailing list, where ZDI wrote, quote, ZDI reached out multiple times to the developers regarding multiple bug reports with little progress to show for it. After our disclosure timeline was exceeded by many months, we notified the maintainer of our intent to publicly disclose these bugs, at which time we were told, you do what you do, unquote. So, for all of our listeners, not much imagination is required to know what's going to happen next. The Exim email message transfer agent system is open source and is thus wide open for inspection by anyone. And the ZDI write-up says that the flaw is in a component that handles authentication. So now the world knows that somewhere around 3.5 million of those servers, all of which are publicly exposed to the internet, contain multiple classic, remotely exploitable buffer overrun flaws enabling remote code execution. So, get yourself some popcorn, get comfortable, sit back, relax, and be glad that you're not running a not yet patched Exim server on your network. And watch what happens next. I have a feeling we'll be talking about this for at least the next couple weeks because, as we know, even if patching was made available and the people running the servers were notified, there would still be, an exponential curve of patching with lots of machines never getting the message, being on their networks and being left unpatched. The bad guys don't even have to reverse engineer from the binary. They could just go, ooh, good, let's just read the code and find the problem. So that's the world we live in today. Speaking of Bleeping Computer, they carried another piece of news recently, this one with the headline, Bing Chat, Responses Infiltrated by Ads Pushing Malware. And of course, Bing Chat is AI-powered now. Bleeping Computer explains. They said, malicious advertisements are now being injected into Microsoft's AI-powered Bing Chat responses, promoting fake download sites that distribute malware. Bing Chat, they wrote, powered by OpenAI's GPT-4 engine, was introduced by Microsoft in February of 2023 to challenge Google's dominance in the search industry. By offering users an interactive chat-based experience instead of the traditional search query and result format, Bing Chat aimed to make online searches more intuitive and user-friendly. In March, Microsoft began injecting ads into Bing Chat conversations to generate revenue from this new platform. However, incorporating ads into Bing Chat has opened the door to threat actors who increasingly take out search advertisements to distribute their malware. Furthermore, conversing with AI-powered chat tools can instill unwarranted trust, potentially convincing users to click on ads, which is not the case when skimming through impersonal search results. This conversational interaction can imbue AI-provided URLs with a misplaced sense of authority and trustworthiness. So the existing problem of malvertising in search platforms is amplified by the introduction of AI assistants. The fact that these ads are labeled as promoted results when the user hovers over a link in Bing Chat conversations is likely too weak of a measure to mitigate the risk. Malicious ads spotted by Malwarebytes are pretending to be download sites for the popular Advanced IP Scanner utility, which has been previously used by Romcom Rat and Somnia ransomware operators. The researchers found that when you asked Bing Chat how to download Advanced IP Scanner, it would display a link to download it in the chat. However, when you hover over an underlined link in a chat, Bing Chat may show an advertisement first, followed by the legitimate download link. In this case, the sponsored link was a malvertisement pushing malware. Okay, so as we know, it's not that malvertising is new. It's not. But we know that the human factor is an enduring vulnerability. It's the reason why phishing attacks remain among the most successful, no matter what else everyone does. So I think their point is a good one. There is something more, cozy and personal about chatting with an AI. For many users, it will seem more authoritative. So things it recommends will have more salience than links appearing in a typical Google search. If you couple that with Microsoft's decision to monetize this facility through real-time ad delivery, and if bad ads are able to slip past Microsoft's screeners, as Malwarebytes has found is happening, then that's a formula for an updated form of exploitation. We do have, however, some good Microsoft news. They're rolling out support for Passkeys in Windows 11. Last Tuesday, exactly a week ago on the 26th, Microsoft announced sweeping improvements to the Windows 11 desktop experience. Among those is support for Passkeys. This had been available in the Windows Insider program since June, but with last week's big update, Passkeys are now available for all Windows 11 users. Under Windows 11, Passkeys are created through Windows Hello. Users can manage their saved passkeys by heading to Start, then Settings, then Accounts, then Passkeys. So there is now a Passkeys entries under Accounts, which is under Windows Settings. Now, Microsoft says Passkeys on the Windows 11 on the Windows 11 desktop will work with popular browsers, including its own Edge but also Chrome and Firefox. What's unclear at this point is what that means when one of those browsers contains its own support for passkeys. Chrome, Edge, Safari, and Opera all currently support passkeys natively. So how does that interact with the underlying OS support for passkeys? And, of course, cross-browser support through add-ons is coming soon. So, okay, now there's a third player who's also going to be supporting passkeys. It's going to be interesting to see how all of this sorts out. And of course, we have the problem that the passkeys themselves, as we know, are not readily transportable cross environment. It is possible to create another passkey in a different environment, but that just creates basically a fork of your logon credentials with separate passkeys in separate environments. So again, we're gonna have to see how this all works. Two other things, though. In the past, we've talked about the power of whitelisting applications that have been approved to run. So two other notable enterprise-related features have also appeared in this update to Windows 11. One is enhancements to the built-in Windows firewall. The other is a new custom app control option to ensure that only approved and trusted apps are allowed onto devices to protect endpoints from rogue code. Microsoft said, as part of this, they said by preventing unwanted or malicious code from running, application control is a critical part of an overall security strategy. Application control is often cited as one of the most effective means, they said, of defending against malware. And I definitely agree. It is annoying in any system that's inherently dynamic to have this, since any changes require multiple steps. But dynamic systems are also the ones that are in the most danger because things are changing on them. So, it's a classic case of you can either have security and jump through hoops in order to allow something that is not currently whitelisted to get trusted and whitelisted. And of course, whitelisting is no good unless you're very careful about that process, or not. You could just leave your system wide open. So I do commend Microsoft for creating the option for users of Windows 11. It is, under any circumstances, definitely a good thing. Okay, now here's a case where the tech press got a little overheated, but it's certainly interesting, if nothing else. A team of 7 Chinese researchers at 3 different universities have done some interesting work. And when I began writing this up, I used the term amazing work rather than interesting. Their work is amazing, but their results are only interesting due to the impractical number of preconditions that need to be established in order for this to work. And as we'll see, it renders it mostly of academic interest. Stated another way, it kind of worked in the lab. Despite that, predictably, most of the headline-driven tech press went nuts over this because the research paper, and I guess a lot of the press just read the headline, it was published a few weeks ago, titled "Password Stealing Without Hacking, Wi-Fi Enabled Practical Keystroke Eavesdropping." None of that is true, but makes a great headline. Having actually read the paper, the issue I would take with their paper's title would be over their choice of the word practical. However, if you change the word practical to barely theoretically possible on a good day when the wind is blowing in the right direction, unfortunately that takes a lot of punch out of the headline.
Yeah, it does, yeah.
And they do deserve to have some punch because what this group of researchers managed to pull off, given a bizarre side channel, is impressive, even if it isn't even remotely practical. And of course, we can never fully discount Bruce Schneier's observation that attacks never get worse, they only ever get better.
Other way around. They never get better, they only get worse.
No.
Oh, I see what you're saying. It depends from whose point of view. From the bad guy's point of view, they only get...
Correct.
Right, okay.
Yes, because they're the attacker.
They're getting better.
Exactly.
Yeah. If you're the victim, they only get worse.
That's right.
Yes.
Yes. Okay, so the underlying enabling technology that these engineers went for is the result of very clever engineers trying to squeeze ever more bandwidth out of an already bandwidth constrained environment. 10 years ago, a feature known as beamforming was introduced in Wi-Fi 5, more formally known as 802.11ac. The idea behind beamforming is simple physics, but it's still somewhat mind-boggling to imagine that consumers are able to purchase something that does this without even knowing about it. Modern Wi-Fi access points contain multiple antennas. Individually, each antenna is omnidirectional. It sends and receives uniformly in all directions. But collectively, some magic can happen. If the access point wishes, for example, to send a stronger signal to a receiver that's directly in front of it, sending the Wi-Fi carriers in phase from its antennas will result in each antenna's carrier, radio frequency carrier wave, summing with the others to produce the strongest signal where they are all in phase, which is either directly in front of or directly in back of the antenna array. But what's cool is that off-axis, the physical distance between the access point's individual antennas will cause the individual radio frequency carriers to become out of phase with one another. That is, off-axis. The carrier waves will stop summing together to create a stronger signal and will even work to cancel each other out. In other words, a properly driven antenna array is able to deliberately form transmission beams where the phases of their carrier signals align to strengthen their signals, and it will create dead zones where their carriers cancel each other out. And this can also work in reverse on the receiving end to cause the array to be selective about where it is listening with the greatest sensitivity. Again, the physics of this is simple, but the idea that this is actually going on and that we all now just take it for granted boggles the mind. Okay, in order to pull this off in practice, the access point and each of its many mobile subscriber radios need to establish an explicit side channel where they're able to interact, not about the actual user data that may be flowing back and forth, but about the channel's metadata, which describes their wireless relationship with all this beamforming in real time. There's a whole other dialogue going on in the background. This metadata is known as BFI, beamforming feedback information. In real time, Wi-Fi 5 802.11ac devices, including smartphones, are sending back detailed information about the signal they're receiving from the access point base station to which they're connected. Now, okay, remember back in 2010, Apple hit a road bump on their way to world domination with the iPhone 4. It turned out that the redesign of the phone's antenna system resulted in the phone's radio performance being unduly sensitive to its user's grip and hand position. This was, the term that was coined for this was antenna gate, which led to Apple's official statement at the time, which read, quote, this is Apple, gripping any mobile phone will result in some attenuation of its antenna performance, with certain places being worse than others, depending on the placement of the antennas. This is a fact of life for every wireless phone. If you ever experience this on your iPhone 4, avoid gripping it in the lower left corner in a way that covers both sides of the black strip in the metal band, or simply use one of many available cases, unquote, they said. In other words, this physics of radio and antennas and the radio attenuating properties of people's water-laden hands and fingers remains true today, though in the case of Apple's iPhones, they've learned some valuable lessons and is less of a problem for them. What these intrepid Chinese researchers discovered and then wrestled to the ground was that the motions of any smartphone user's fingers as they moved them around their phone's touchscreen while entering passwords, passcodes, and so forth, what should be completely private information will naturally affect their phone's real-time signal reception, and that today's 802.11ac devices will be broadcasting the details of their phone's hand motion affected signal reception in the clear and without encryption in real time back to the access point and also to anyone else nearby who might be interested in receiving and interpreting it. Okay, so the interpretation is the trick, which is why I characterize this as barely theoretically possible on a good day when the wind is blowing in the right direction. Essentially, they're getting nothing more than the one-dimensional received radio signal strength information, and they're managing to turn this into, something. If they highly train a powerful recognition system on a single specific setting and individual who's not changing the grip on their phone, where the system has already learned to associate the beamforming feedback information related signals to what's being entered, then under all of those constraints, their research shows that they are able to determine a single numerical key that the user has entered, and we should really say re-entered, with 88.9% accuracy. Considering that all they're receiving is the smartphone's received signal strength in real time, that's still impressive. But despite all of their work, and through no fault of theirs, it falls far shy of justifying headlines such as these three, which were just recently printed. Exploit steals passwords by tapping into keystrokes. And new cybersecurity threat, WikiEave, allows hackers to steal passwords. And finally, using free Wi-Fi? Better watch your passwords. In other words, you don't have to be worried about anything. If anyone may have encountered any of those or similar headlines in the past few weeks, I think it's safe to say that your personal keystrokes remain safe from arbitrary harvesting in public Wi-Fi settings.
What a relief.
Yes. Bruce is right that attacks only ever get better. That is, the strength of attacks only ever increases. But the limitations inherent in this one to a single previously trained instance means that it's only of theoretical interest at best. And I did want to just note that while I was looking up Apple's iPhone 4 statement, I was greeted by Engadget's pop-up, which said, "Review your global privacy control preferences." And it said, "You're using global privacy control." Right. How dare you? They said, "This leads to a lower quality experience on Yahoo by blocking certain editorial content, including embedded tweets and YouTube videos, and," this is what they really care about, "third-party ads that are relevant to your interests." Anyway, we discussed this before, where it then goes talking about the technical identifiers which they use, and we looked at those too, and they're truly horrifying. So anyway, I was offered the option of allow or don't allow, and I already got what I wanted, so I said thanks anyway, and went elsewhere. So Leo, we're going to close the loop with our listeners, but I think we should take our second break, and then we're going to dig in.
All for that.
Wondering why there is no Nobel Prize for math.
There's the Fields Medal, which is the Nobel Prize of math prizes, but not Nobel.
Correct.
Yeah. Well, good. I'm glad. I want to know why. That's a good question. It's a reasonable question. They just awarded the Nobel Prizes for physics and medicine, but not math, because there is none. Our show today, there should be a Nobel Prize for VPNs. And if there were, my friends, it would go to ExpressVPN. Why would they? How would they? What would make them the Nobel Prize winners? Well, first of all, actually, there's so many reasons. It's the only VPN I use. First of all, because they truly protect your privacy. You see, when you're using a VPN to protect your privacy, to keep your internet service provider, for instance, from seeing what you're doing online, because they sell that on. It's completely legal for them to do that. They're middlemen, in effect, selling all those digital footprints you leave online. They stitch together, the brokers then stitch together detailed profiles, not just your browsing history and your searches, but location data. I mean, everything. And then they sell that profile to a company. Well, it says here who delivers you a targeted ad, but it could also be to a country like China that's spying on you. That's why I never worried about TikTok, because data brokers were the real threat, right? You might be surprised to learn these same data brokers are also selling your information not just to China and advertisers, but the Department of Homeland Security and the IRS. You might want to hide your digital footprints. And ExpressVPN, Nobel Prize winner in VPNs, is the way to do it. They go the extra mile to make sure that they know nothing about you. Because when you are moving, all your private data away from the ISP to a VPN, you're giving them the data, because that you have to emerge somewhere on the public internet. You got to trust the VPN server, the provider, and ExpressVPN really, first of all, they created their trusted server technology, which when you click that big button on the ExpressVPN app, spins up a server that only you are using in RAM. Sandboxed. It can't even write to the hard drive. And then when you close it, it's gone, as is every trace of your visit. But just in case, they also run a custom version of Debian Linux that when every morning they reboot the machine, it wipes the drive, starts over, fresh install. They don't want your information, let alone sell it off. They don't want to know. That's why you want to use ExpressVPN. They also invest in their network. Now, it's not a free VPN. Costs you less than $7 a month with our deal, but still, it's not free. But you want to pay for your VPN because you want them taking that money and investing in infrastructure, not just the trusted server, but also enough IP addresses and rotating the IP addresses so your IP address isn't readily distinguishable as a VPN IP address. You want them to have enough bandwidth so you can watch HD video. That's another benefit, of course, is you eliminate geographic restrictions. You can watch Netflix in Japan or the UK, for instance, if you're a Netflix subscriber. But to do that, you need enough bandwidth, right? ExpressVPN's got it. And of course, when you're connected to ExpressVPN, your personal IP address is not visible. It's ExpressVPN's IP address, which, as I said, they rotate. 100% of their traffic is encrypted. Of course, that's a given. The app is easy to use and it works everywhere: iOS, Android, Mac, Windows, Linux. But you can also put it on your router. They support a variety of routers. They even sell some very good routers, by the way, in the ExpressVPN store. So then the whole house is protected. And I have to tell you, they're so fast, no one's going to say, hey, what happened to the internet? It's fast. You won't even know. In fact, I know that because I've often turned on ExpressVPN and then forgotten to turn it off for months on a device. It was on my iPad the other day. I said, oh, it's on. It's been on since July. Make sure your online activity and data is protected with the best VPN money can buy. If there were a Nobel Prize for VPNs, it would be ExpressVPN. Protect yourself with a VPN I use and trust. Go to expressvpn.com/security now, the whole name right now, and get 3 extra months free. That's a special link just for you when you buy a 1-year package. EXPRESS, Express, they spell it out. I like that too. VPN.com/security now. Please use that address so they know you saw it here with Steve. expressvpn.com/security now. So why is there no Nobel Prize for mathematics, Steve?
Okay, so a little bit of context from last week for you, Leo. We had a listener who wrote to me and said that I was incorrect in an earlier statement I had made that no mathematical algorithm could be used to generate truly random numbers. He said he had invented such a mathematical algorithm, I think it was 45 years before, and was surprised that no one had done that since. So I sort of, I explained why I still believed that it was not possible for a deterministic mathematical algorithm to produce truly random numbers, and suggested that if he actually had such a thing, he could probably win a Nobel Prize for math. Anyway, so Jacques Jarnell said, "Hey, Steve, quick correction to the last pod episode 941. There is no Nobel Prize for math." So seeing that surprised me, since it would seem that there's a lot to math that might be prize-worthy. And there turned out to be a few interesting bits surrounding this. What I immediately encountered was the statement that on the internet, of course, where everything is true, no Nobel Prize is awarded for mathematics because a mathematician was carrying on an affair with Alfred Nobel's wife.
What? Oh my God!
Now if that would be quite petty, I think, to punish all future mathematicians throughout time. So Snopes, however, disabuses us of that fanciful notion. They explain the renowned Nobel Prize is the legacy of Swedish chemist, inventor, and industrialist Alfred Nobel, whose 1895 will specified that most of his fortune be set aside to establish a fund for the awarding of 5 annual prizes, quote, to those who, during the preceding year, shall have conferred the greatest benefit on mankind, unquote. The first Nobel Prizes were distributed on 10th of December, 1901, the 5th anniversary of Nobel's death, for achievements in the fields specified by Nobel: physics, chemistry, medicine, literature, and peace. And then a 6th prize was added, a 6th category. The category of economics was added by the Bank of Sweden starting in 1969. And Snopes continues, in the century since the Nobel Foundation was established, many have speculated on the reasons why Alfred Nobel did not provide for a prize to be awarded for achievement in the field of mathematics. Surely an eminent man of science, such as Alfred Nobel, could not simply have forgotten about mathematics, so he must have had a good reason for omitting it. With no obvious reason at hand, people invented one, and as usual, the invented tale had a bit of salaciousness to it. It was said that Alfred Nobel deliberately avoided establishing a prize for mathematics out of vindictiveness because a prominent Swedish mathematician was carrying on an affair with his wife. However, what a little problem with that. The wife theory is easily discounted since Nobel was never married.
Oh, well, there you go.
Yeah. I'll also note that the Nobel Prize Internet Archive has an extensive page addressing this question, since it has obviously puzzled many others. However, to read that page, you'll need to tell your browser that it's okay to visit, since it's HTTP only. So, Wiser tweeted from @Wiser. He said, "Hi, Steve. Thanks for the show. Just a short note. The Nobel Prize is not awarded for mathematics. Mathematicians, as you said, Leo, can only hope for the Fields Medal. Greetings from Stockholm." Vampire tweeted @SGGRC, "Why not establish a presence in the Fediverse? It's open nature seems right up your alley." So just to address that, it's just a matter of being spread too thin and of needing to maintain a presence in too many places at once. At the moment, I have email and GRC's old school text-only news groups where I spend the bulk of my time, since there's a core group of similarly focused people there who are of incalculable value to me in helping to move projects to completion. And GRC now maintains web forums, and I still have Twitter, which remains effective. So adding yet another venue to the mix would take away something from the others. If anything, what I would prefer to do is to consolidate rather than further spread things out. Someone whose handle is True No Limit, he said, "Hi, in regards to LastPass, is the email attached to the encrypted blob the only way bad guys know what blob to spend money decrypting?" He said, "When I signed up for LastPass, I made a brand new email that was never used anywhere else." He says, "I don't even get spam to that email." Right, because, you never exposed it, apparently. Okay, the answer is, unfortunately, no. Email is not the only way. For reasons that were never made clear, since it would not appear to be necessary, the user's logon URLs were also left unencrypted in the LastPass vault. This means that scans of the vault could be used to profile users' interest in cryptocurrency-related sites to identify potential higher value targets where decrypting their vault may reveal something that could be used to drain their money. So given that, it's hard to imagine that the bad guys would not do so after they've finished decrypting the vaults of other lower hanging fruit that seem, maybe hiding some money. Simon Zarafa tweeted, "Blocking AI scraping and similar from your websites, robots.txt and other measures to try to keep content from AI training models." So Simon tweeted a link to a lengthy post by someone named Neil Clark, which was titled, "Block the Bots That Feed AI Models by Scraping Your Website." So I've included the link in the show notes in case it might be of interest to our listeners or someone our listeners know. I have no interest in blocking bots of any kind from any of my content anywhere, since it seems to me that AI bots may be the next generation, internet search tool, as we talked about before with Microsoft's Bing bot. So I'd like to have GRC well represented in the learning models of AI things, but the short version is that the well-known robots.txt file in the website root directories can also be used to block AI bot scraping, just as it does for other sorts of web spiders. You need to know the name of the user agent that the bot uses. For example, the string CCBOT stands for Common Crawl Bot, which is used by ChatGPT, Bard, and others for training a number of their models. Anyway, if you're interested in excluding AI training on your site's content, though it's likely too late for what's already been crawled, there are presumably ways to do that moving forward. I've got a link in the show notes that lists all of the various user agent strings that can be used if you want more comprehensive anti-AI bot scraping for yourself. Someone whose Twitter handle is Apple's Oranges said, quoting Google Bard AI. So he says, quote, this is him quoting
Consider
Google
the
Bard.
Source. It's an AI. Okay, go ahead.
He says, so this AI said, "I personally believe that non-deterministic algorithms are not oxymorons. I think that the term algorithm can be used to describe any process that can be broken down into a series of steps, regardless of whether or not the process is deterministic. In fact, non-deterministic algorithms are used in a variety of applications, including machine learning, artificial intelligence, and cryptography. They're often used to solve problems that would be difficult or impossible to solve with deterministic algorithms, unquote. Okay, now, that statement begins with, I personally believe.
Problem number one.
Which puts me off, yes. It puts me off a bit since Bard is not a person. So I wonder whether a non-person is able to personally believe anything at all, not to mention whether a machine can have beliefs. I suppose if it said, my simulated personality believes, that would at least seem authentic. We are stepping into a weird world here.
Yeah, we are. Yeah.
Leo, I have an exceedingly, and I mean exceedingly, bright friend of many decades who has been spending a great deal of time chatting with one of the AIs. I don't remember which. And he assures me, and the problem is I really respect this person's opinion. He assures me that over time, with proper grooming, a true personality emerges. And he did tell me that apparently praising it helps a lot.
My point would be, where does that personality come from? It comes from him, the person, right? The person is and this is my big problem with a lot of conversation about AI is we humans applying this layer of anthropomorphism on top.
Yes, that's exactly the right word. Yeah. Anthropomorphism. Right. I mean, cats look like they have something in mind.
Sure. They're thinking,
stuff.
Sure. Right. No, they're not.
It's like staring at you thinking, basically it's, where's my dinner?
This is how humans work. We do that, but it's not, it's a machine. Now, what about what it says about non-deterministic algorithms?
Well, yes, as for whether the phrase non-deterministic algorithm is an oxymoron, I will readily concede that the phrase is used by people who don't consider it to be oxymoronic. But mostly I was just having fun when I was talking about this before, and I believe it's still clear because I didn't say, it was this other guy that talked about a non-deterministic algorithm. I was talking about deterministic algorithms, and I believe it's still clear that any fully deterministic algorithm cannot produce truly random numbers, which, as I said, was my original statement. It was our listener who introduced the idea of non-determinism about algorithms, and I was just, algorithm can you have an algorithm that is not deterministic?
I'll give you an assertion.
An algorithm
cannot
can be
produce
tossing
a truly random number, I would suggest, right?
If it were staring at the wall of lava lamps,
or it had a capacitor hooked up, or some other physical.
Yeah, and so if you say that an algorithm is flipping a coin, then okay, but again, it really comes down to our definition of algorithm. Is an algorithm 1 + 1 = 2, or is can you say that the algorithm is ask a random number generator for a number? Well, if that's what you're going to do, then I don't think that's an algorithm.
We know that quantum computing is not deterministic. That's its chief advantage, right? It's neither on or off. It could be any variety of states. We know also that fuzzy logic, we talk all the time about using fuzzy logic or fuzzing, right, to solve security issues. That's not deterministic, right? It's kind of randomized inputs.
Yeah, although it doesn't have
deterministic, I guess.
There it could be pseudo-random, but okay. So, for example, the one of the best ways to generate for a little box to generate random numbers is to force current backwards through a diode.
Right.
You reverse BIOS a diode, which does not, it wants to prevent any current from flowing. What it turns out is that there is some noise of individual electrons just through heat and I mean, true quantum level stuff crossing over that boundary junction in a diode. You amplify that and you clean it up, and that is a source of true entropy. And so that's what all the little boxes that say, contains a true random number generator, that's what they have. You could also use a Geiger tube and stick it out,
right.
Hold it up in the air. And when a neutron or whatever the heck it is flies by, or a charged particle passes, it's like, oh, look, I heard a tick on my Geiger tube.
These are essentially chaotic inputs, unpredictable inputs.
Exactly.
Somebody says in the Discord, and I think this is actually a good definition, non-deterministic algorithm would be different outputs for the same input, which, by the way, most of the time in programming is something to be avoided, right? The problem with pseudo-random number generators is eventually they repeat because they aren't really random. But a diode, backwards diode, or a Geiger counter, it's going to be truly random.
Yeah,
I guess a die is random, except there's little influences from the shape of the die.
Yeah, if you actually, if it's not perfectly manufactured, and also, dies have different number of divots on their different faces.
Right.
So
it's going to.
Has anyone ever actually taken the time to compensate for that? I don't know.
No.
No.
And we know that you can load die by shaving them, just changing the weight of one side slightly.
Yes.
So that's sufficient. So
Leela,
go ahead. I love this subject because
it is a fun subject.
And to me, that is the criterion I use to determine between AI and coding. Algorithms are inherently deterministic, in my opinion. But an AI, because it's creating its own algorithms, is non-deterministic in that sense. So if it's machine learning or a generative adversarial network or something like that, it's writing its own rules, not a human. It may still be, frankly, a deterministic algorithm, but we don't know what's going on inside that black box. So from our point of view, it isn't. That to me is AI. But so I'm curious. It's mostly semantic. We know what an AI is.
Yep. So Leela Burrell Davis, she's tweeted, she said, "Hi, Steve. I just came across an excellent introduction to Syncthing on YouTube and thought you might be interested in recommending it to your Security Now listeners. It's very well made, and the author is clearly not only extremely knowledgeable, but knows how to explain things to a technical audience. It's made me think that maybe Syncthing is not too hard for me. Have a quick look. I'd be surprised if you don't watch the whole thing. Syncthing made easy." Anyway, because I was in the middle of compiling the show, I was unable to take the time to watch. But I quickly scanned the 30-minute video's 165 comments of universally strong praise.
Wow.
Since Syncthing can be initially somewhat off-putting and confusing.
Oh, this is TechCraft. Yeah, they do good. He does very good stuff. I would trust him. Yeah.
So I made it our shortcut of the week for any listeners who've heard Leo and I, because both of us love and use Syncthing. grc.sc/842, today's podcast number. grc.sc/842. It's about, I think it's 28 and some seconds long, 28 minutes long. And apparently, it's great.
Yeah, it looks pretty good. I agree with you.
I recommend it.
With my cursory scan of the thumbnails, it looks pretty good. Yeah.
So, Furist Opus, he said, you suggested neutering what HTTP sites can do to prevent what happened in Egypt. But I was wondering, couldn't the middle box redirect send him to a malicious HTTPS site? If so, scripting on HTTP sites isn't the problem. The HTTP connection is what's vulnerable. Thanks, Scott. And I think that's a very good point. Since the middle box was returning a 307 temporary redirect and the URL bar was going to be changing anyway, as a result, it would be less worrisome if the redirect was to a secured HTTPS site where the malware was delivered. So I think that's a very good point, and I just wanted to share it with our listeners. Someone whose his picture in Twitter is a Cookie Monster, and of course his handle is Cookies. He said, "Hey, Steve, what happens when the person responsible for securing the family's digital life, photo storage, general storage, accounts, etc., unfortunately and suddenly passes away? Since becoming a family man many years ago, I've been thinking about the best way to approach the conundrum. Will your loved ones know what to do if you get run over by a bus or hit by a train? The conundrum comes when there is that one person in the family who has set up all the accounts, the multi-factor authentication, the recovery codes, and so on. The other one loves them, so puts up with all the extra hoops that they're being made to jump through, but may not fully understand all or any of it. The issue is the line between ensuring there are no weaknesses in your setup versus ensuring your loved one has enough information to figure out how everything works and is able to access the family photos, digital files, and everything else. Anyways, love to hear your thoughts on the matter. P.S. I have limited time to listen to podcasts and audiobooks, so unfortunately, I had missed the last 8 months as I got up to book 14 of The Silver Ships.
Oh, wow.
Once you mentioned it! Exclamation point.
That's hysterical.
And he said, plus, Leo and his screensavers was the reason I asked my parents for satellite TV when I was 14 in the early 2000s.
Now I feel old.
Signed, Matt from Australia.
Yeah, way to go, Matt.
So I included Matt's question, even though it's not a new problem, due to its importance, which I think endures. The question, of course, is how would the people we care about fare if, for whatever reason, we were to become unable to guide them through the process of unlocking whatever we had secured from the rest of the world? The related problem is that this is also something of a moving target. Perhaps we did, at some point in the past, take a snapshot of our security precautions, passwords, etc. Is that snapshot still valid? Over time, we tend to make changes, like perhaps moving away from LastPass. But that suggests that we should periodically revisit our preparations. So anyway, just a reminder about that.
In my desk drawer, in case anything happens to me, Steve, tell Lisa this. I have a piece of paper that says, in the case of my death or dismemberment. And inside is all the passwords. I even taped a YubiKey in there, my backup YubiKey in there. But also Bitwarden and LastPass and most password managers have a way to specify an emergency contact, a recovery contact. So I've done that with Lisa and other family members for my Bitwarden. In fact, when we got our new iPhones, I noticed you can do the same thing with your iPhone. You can specify an emergency contact. Not contact's wrong because it's after your death or incapacitation. But an emergency person who has access to your account. And so I've done that also. And in fact, I told Lisa and our son Michael about it, and we did that all. And I think there's a increasing awareness of this.
Good.
And you're right. You got to keep it up to date. Although if you do it the way Bitwarden and Apple do it,
yes,
you don't have to worry.
Right. If you provide a means to get in to your master set of secrets, then the changing secrets are always current whenever anyone gets in.
Exactly.
So,
yeah.
Good.
Apple calls it account recovery contact.
Account recovery contact.
Account recovery.
Interesting.
Contact, yeah.
Well, it'll be interesting to look at how that works exactly, because
this one maybe requires you to still be alive.
or maybe it requires you not to deny their attempt.
That's how Bitwarden works. It's a dead man switch. So they send an email, and you set the time span, and you say, if I don't respond in 7 days, give her access.
Let them in.
Yep.
Good. So Mark W. Clemens said, I received a series of three I received a series of 3 interesting tweets from Mark W. Clemens. He said, first, hi again. Maybe you or Leo could cover some security solutions with Shop Pay. He says, parens Shopify. He said, I get stuck using it every once in a while as a customer to a store like Boll and Branch. It will not take a privacy card, and I'm unable to delete my credit card later. The concern is the capture of credit card information when, not if, Shopify gets penetrated and customer data is stolen. Thank you, Mark Clemens. And he says, parents, using my name is fine. I'm your age and hard to embarrass. So then I got an update tweet. Update, he said, I received this from http://privacy.com. And he said, ShopPay just attempted to charge $0.00 to your Shop Pay card, but the charge was declined because we've detected multiple cards used at Shop Pay. This behavior is prohibited on our system to prevent exploitation of new customer or referral promotions. If you have a special use case which requires this, please reach out directly to our team at support@privacy.com. And then the third tweet from him. He said, I sent you a DM on Twitter about http://privacy.com. And now I am getting calls from unknown individuals asking if I need credit card help. Is Twitter monetizing the content of private DMs? I think I will join you in leaving Twitter. This was just too coincidental. Okay, now this, of course, is all anecdotal. But Twitter is objectively hemorrhaging cash, and we're learning more about Elon every day. So would anyone put it past him to monetize our supposedly private DMs? They're only private in as much as they're only readily available to the conversation's participants. Twitter never purported to be Signal, WhatsApp, or iMessage. And who knows what the fine print in the terms of service say. And just to keep some perspective here, Google does something similar, as we know, with our email, which is private only, to about the same degree. Anyway, so who knows? Anyway, just a heads up about something that might be happening in case anyone else cares. I don't know one way or the other. CPU Guru said, Bitwarden was warning me to update my PBKDF2 iterations and suggested that I export my passwords before I did it just in case. Tried to do so under Edge, and it was blocked by Microsoft Defender Smart Screen as a, quote, potentially unwanted app, unquote.
Yeah, sure.
He said, had to log in under Chrome to do the export process, legacies, he said. So I included this here because I am certain I'll be announcing the general availability of GRC's Valid Drive mass storage fraud detection utility on next week's podcast. Except for a few typos and some cosmetics that I need to fix when someone has scaled their font sizes to other than 100%, it is finished and it's been running beautifully for some time. But it will be a brand new Windows utility when it's released, and Windows has become insanely overprotective about anything that has not yet had the chance to establish a reputation for itself. The perceived safety of code is no longer about what it does or what it might do. It's all about its reputation. And annoying as that is for me, being a developer of always brand new code with no pre-existing reputation, I 100% agree with and endorse this policy. Unfortunately, reputation is the best defense we have today. And for what it's worth, once Valid Drive has established itself, much as the DNS benchmark, In Control, and GRC's many other freeware utilities have, it won't cause anybody any trouble. But initially, I could expect that it will, and I'll remind everybody about that again next week, because what our testers have been testing the versions of Valid Drive, and in many cases, they've had to fight with Windows in order to get a copy to run, even though they just freshly downloaded it from GRC, and I just built it from the source code. It's like it's minutes old. But unfortunately, that's part of the problem these days. Matthew N. Dudek, he said, related to your discussion about securely erasing drives, Windows 10 has a function to reset the PC with a clean the drive option so that the PC can be repurposed and reused like it was new. Is the drive cleaner a secure enough erasure to prevent data from being recovered? I have old PCs that were used in a medical office. I want to give to another organization and want to make sure nothing can be recovered. Okay, so I poked around a bit to see whether I could determine what Windows is doing. But Microsoft isn't being very clear about that, and I didn't take the time to set up Windows and do a clean the drive option and see what is left. So at the moment, of all the things that have been suggested, I really like the idea that was suggested by one of our listeners of using VeraCrypt to encrypt the entire drive with an insanely long and then discarded password. It's a terrific and relatively simple way to cause ultra high quality pseudo-random data to be written to the entire drive. Since VeraCrypt has a portable operating mode, it doesn't even need to be installed. It can be run from a thumb drive. And if you just type a bunch of gibberish into the keyboard for your password and encrypt an existing drive that way, and then throw that password away, you've just filled your drive with absolutely strong pseudo-random data.
Although this is the argument for turning on file encryption before you use any media.
Yes.
And
yes.
Now on Mac, it's on by default. File vault's on by default. I guess BitLocker is not available in Windows Home, or is it now?
You're right. I think it's not available on
both iOS and Android. As far as I know, the phones are encrypted by default.
Correct. There is on-the-fly hardware encryption on the drive. So it's just a matter of discarding that key, and the entire drive is no longer recoverable.
Whenever, especially on an SSD, as we've talked about, but in general, whenever I set up a new drive, I make sure they're encrypted. That way, I don't even think about it, right? Because it's just garbage on that platform.
Right.
Even the Slack space.
Right. Neil Baldridge said, "Hi, Steve. Over the years, there have been various discussions about battery health, charging, etc. And I recall you talking about it being best to keep a lithium-ion battery charged to minimize the charging cycles." He said, "Our company has been moving from ThinkPads laptops to Microsoft Surface laptops, and I've noticed that mine, a Surface 5 laptop, wants to keep, quote, smart charging, unquote, on unless I override it. Smart charging caps the battery charge at about 80%. If I need to have a full battery because of running disconnected from power, I have to remember to disable smart charging early enough to get a full charge. Then, after a day or so, it will enable it again and limit the charge to about 80%. Do you know if something has changed with laptop battery health? Or maybe my understanding is just out of date. Thanks for all your contributions, and I too am grateful for the extension of Security Now."
First thing I would say, by the way, is if you keep it plugged in, you're not stopping charging. It discharges a bit and recharges, discharges a bit, recharges. There is no way to not keep a battery from charging by keeping it plugged in. It's going to discharge over time, and you're going to charge it. So his first premise is false.
So his information's not out of date. What he's referring to is a subtlety that I think I may have failed to make clear enough in our earlier discussions of this. While it's true that unlike their NiCad predecessors, lithium-ion batteries do not like to be deeply discharged, they also really do not like to be overcharged. Overcharging a lithium-ion battery is really, really bad for them. So what's happened is that various laptop manufacturers have started getting smarter about their battery charging. When they notice that the machine tends to be plugged in all the time, they'll deliberately begin resting the battery at some lower charge level, which is much safer for its cells. Then if the battery is about to be used, as Neil said, you'll want to top it off shortly before going on the road. So it actually is smarter if you just generally use your laptop in an at-home docked and plugged in way, setting it up so the battery is not always fully charged, but is something more like 80 to 85% charged, is better for the battery health.
No modern device you're buying will let you overcharge a lithium-ion battery. None. In fact, the last time that happened, those hoverboards, they burst into flames and were immediately banned. Everything you buy today has circuitry to prevent overcharging. You don't have to worry about that.
Yep.
But
exactly.
I think it is often possible to fully drain a battery. There's nothing to stop you from doing that either. So.
Correct. Although actually lithium-ion batteries also have a little circuit on the cell itself that deliberately disconnects it because it does not want to go all the way to zero.
Yeah, I think
that's
you can
also
trust.
Not good for it.
Basically, I always just tell people trust the manufacturer and use those default settings because they know best the hardware. Right. Don't try to outwit them.
Right. Although disabling it in order to go to full charge prior to going on a road trip does make sense.
I do that on my EV. Yeah.
Yeah. And this brings us to the smart recommendation of the week. Kevin Van Heron said, "Hey, Steve, I've been thinking about the issue of securely storing things outside of my cloud. Outside of my cloud-based password manager. We talked about, using your password manager to store the things that were relevant to the web, but unless there's a reason to store other things there, it would make sense to maybe put them somewhere else. Then you're not having the problem of worrying about what else might be decrypted in the event of a cloud breach like we're now seeing with LastPass." So anyway, he said, I wanted a product where encryption was the main goal rather than a compression product where encryption was an add-on. And I had talked last week about using an encrypted archive as a typical solution. He said, "For this reason, I decided to use a password manager, just not a cloud-based one, and one I won't integrate with my browsers." He said, "I'm going to use KeePass XC. It's open source, cross-platform, and uses standalone files. You can include other files, not just passwords, in the encrypted database file. It's been around forever and started by forking the code base of the even older KeePass X. They even recently had a code audit." He said, "Files in the database aren't compressed, but certs and SSH keys are tiny, and disk space is reasonably cheap." And I just wanted to say, I think that Kevin's rationale is sane. I was wondering about the encryption of an archiver that was added as a secondary feature to the encryption, and KeePass XC is a cross desktop platform, Windows, Mac OS, and Linux. So anyway, I just wanted to share Kevin's solution. And Kevin is certainly correct that the size of stored content is no longer a huge issue. And for what it's worth, it could be compressed before it's placed into KeePass if you wanted that too. And you have to do it beforehand because as we know, any resulting encrypted container cannot be compressed because anything properly encrypted contains zero entropy, making it impossible to compress. And one final note, Principal Archivist answered the question he said about mathematicians. He said, "Old mathematicians don't age, Leo. They just get irrational."
Okay.
Okay. So, buckle up now. After you tell us about our third sponsor, we're going to talk about encrypting the ClientHello.
Okay. Whatever that means, get your propellers prepared while I tell you about Collide. Collide solves a big problem in the world. We have good trust solutions. Okta is a great trust solution. Make sure that anybody who signs into your network and uses your network apps is authenticated, is real. What it doesn't address, Collide does. And that's the issue of, yeah, it's the real person. Yeah, it's that LastPass DevOps guy. So we've authenticated him. But what it doesn't do is check to see if he has an out-of-date and insecure version of Plex on his hard drive, which he did. This is where Collide is so great. It's a device trust solution for companies that use Okta to ensure that if a device, not the person, a device isn't trusted and secure, it can't log into your cloud apps. If you work in security or IT and your company has Okta, this is a message for you. If you listen to this show, I think you've noticed that the majority of breaches, the majority of hacks, all have something in common. Sad to say, it's the employees. Now, don't blame the employees. They're the attack vector. That's what everybody's hammering on with social engineering and all sorts of stuff. Sometimes an employee's device gets hacked because of an unpatched program like Plex. Sometimes employees leave sensitive data inadvertently in an insecure place. Maybe their SSH private keys are in their download folder, that kind of thing. And it seems like every day some hacker breaks in using credentials phished from an employee. The problem here, though, is not the employees. It's the solutions you're using to prevent those breaches, but it doesn't have to be that way. Imagine, close your eyes, imagine a world where only known secure devices can access your apps. So the employee or the person is authenticated and their device is guaranteed secure. In that world, it doesn't matter if the credentials have been phished. And you can manage every OS, by the way, not just Mac and Windows, but Linux too, all from your single dashboard in your little IT cave. Best of all, you can get your employees to fix their own device securely without creating more work for the IT team. That's actually my favorite part about Collide. It enlists your employees, your end users, as allies in the fight against bad guys. Well, guess what? You don't have to imagine that world. That's how Collide works. Just start using Collide with your Okta, KOLIDE.com/security now. Do this, book an on-demand demo, because once you see how it works, I think that's when the light bulb comes on. It's really cool. KOLIDE, Collide.com/security now. And we thank him so much for supporting Steve and the important work you do here, Steve. On security.
Okay,
what is hello, first of all? I don't know what you're talking about.
Hello is actually ClientHello is the name of the first packet that our browser sends to a server.
The SYN and the ACK. The SYN.
Well, that's TCP.
Yeah.
The ClientHello is TLS.
Okay.
So it's so
the
after you
handshake,
establish
the beginning, yeah.
Exactly.
Yeah.
Exactly.
Yeah.
So today's topic was inspired by a tweet from Nick Sullivan. We've referred to Nick many times in the past. His title is Head of Research at Cloudflare, where he leads research in the fields of security and privacy, cryptography, internet measurement, and emerging network paradigms. Prior to working at Cloudflare, he developed encryption technology for Apple's Internet Services division. He also co-wrote Symantec's Internet Security Threat Report, which we shared for years. And has degrees in both computer science and pure math. So maybe a Fielding Medal is in his future. So here's what Nick tweeted, and that's the reason we're going to dig into this today. Nick tweeted last week, Encrypted ClientHello, ECH, is a new proposed standard that improves encryption and metadata protection for connections online that use TLS for security. After years of testing and refinement, it's finally happening. He said Chrome has been testing ECH for months and is now enabling it by default in Chrome 117. Firefox is not far behind. Cloudflare just launched support for ECH, again, Encrypted ClientHello, for all customers. These changes, he said, amount to the removal of the host name from clear text for a huge chunk of internet communication. Considering how long the host name has been in clear text and how many products were built around that assumption, it's going to be an interesting rollout. Following Nick's tweet, someone immediately replied to his tweet saying, "What kind of fallout do you expect to see? I'm guessing a lot of enterprise and consumer parental and security controls will need to find new mechanisms. What else?" And Nick replied, "National firewall and content filtering will be affected." Someone else cautioned, "Be very careful about implementing this in enterprise and education settings, as it removes a key indicator of compromise used by cybersecurity defenses. I know many CISOs are very concerned about the implications of ECH, Encrypted Client Hello." And of course, what all of this tells us is that spying on not the content of, but the fact of encrypted HTTPS TLS connections has remained a big deal, and that this new initiative is in the process of taking that away. As Nick observes, quote, "Considering how long the host name has been in clear text and how many products were built around that assumption, it's going to be an interesting rollout." Okay, so let's back up a bit before we move forward. Originally, the web primarily used HTTP. A client, a web browser, would look up the IP address of the domain the user wanted to connect to and make a query. So the browser would initiate then a TCP connection to the remote IP that it had obtained by querying DNS. Then the client, the browser, would send an HTTP query using an HTTP verb, typically get, followed by the URL of the resource to be retrieved from the remote server. The query would often contain some additional query headers, like "if modified since," which would allow the server to check the date of the resource the client was requesting and reply with "not modified," rather than resending something that the client already had. This improved the web's efficiency. So that's an example of a so-called a query header that went along with the query. But the most important query header, which has been mandatory since near the beginning of the web, was the host header. This told the server the name of the host from which the client was requesting the resource that was named after the get verb. In the very early days of the internet, this wasn't strictly necessary, since the host's name was used to look up the IP of the server in the first place. So the assumption was that the server answering TCP connections and responding to queries at that IP would be the host the user expected. But then things became more complicated. We wanted multiple websites to be able to share the same IP address. That would mean that a domain name lookup for the IP of, for example, www.acme.com might return the same IP as a lookup for www.zebras.com. This meant that two different websites were cohabitating at the same IP. And that's what made the host query header then mandatory. If web browsers always included the name of the host's domain that they were querying, then the receiving end could examine the query to hand it off to whichever website matched the named host. And all that worked great. But then along came HTTPS with TLS, and things became more complicated due to a chicken and egg problem. With HTTPS, an initial TCP connection is established as before. But now the client indicates that it wishes to establish an authenticated and encrypted connection by sending a TLS ClientHello handshake packet. The server likely expects this, especially if it has accepted the initial TCP connection at its port 443, which has been standardized for receiving incoming HTTPS connections. But either way, upon receiving the client's ClientHello TLS initiating handshake packet, the server needs to reply with its matching server hello TLS handshake packet. The problem is, in a modern multi-homed environment, which many of where many different possible websites and servers exist, which one should reply? We're wanting to bring up an authenticated connection. So the client needs to receive the server's certificate immediately for verification of the connected server's authenticity. But again, the certificate for which server, which website, which domain. Remember that the host header, which had been handling this for us in a pre-TLS HTTP only world, is part of the client's HTTP query, which hasn't happened yet, since we still don't know who we're talking to, and we have no encryption. Like I said, a classic chicken and egg problem. This dilemma was solved by moving the declaration of which server we wanted, which website or domain we wanted to talk to earlier in the handshaking connection dance. It took the form of an early extension to the TLS protocol, back when it was still called SSL. The extension is known as SNI, which stands for Server Name Indication. So for a long time now, the initial client hello, which opened the TLS handshake, has included a declaration of which website, which domain the TLS handshake should be made with, which is to say, which server or domain should reply with a TLS certificate that's valid for the domain indicated by the client's SNI enhanced client hello packet. And so once again, all that worked great, but Houston, we still have a problem. Even though we're now using TLS to securely authenticate and encrypt our communications, once the channel has been established, the identity of the server that the user is connecting to is still out in the open as plain text for any and all to see. The SNI extension data is sent in the clear so that the proper server may be selected for a response. And anyone, any ISP, any carrier, any government, any censor, or malicious intermediary is able to monitor what amounts to HTTPS and TLS connection metadata. Okay, so now what? The first attempt to resolve this conundrum was known, not surprisingly, as ESNI, which of course stands for Encrypted Server Name Indication. Okay, so if the client is going to encrypt the server name indication extension data, the question is, encrypt it with what? What encryption key is it going to use? How can the web browser encrypt the SNI data for a server that it wants to talk to before it's ever talked to it? Our mission today is to go in. We're going to go into this, but beware that, as I said at the beginning, quite unfortunately, we are rapidly entering the land of the kludge. And it's not going to be getting any better anytime soon. In fact, it's going to be getting even more kludgy the more and more fully the brightest minds in the world attempt to solve this problem. The short version is, this problem did not have any good, clean solution. And the longer version is, yeah, but we still needed to solve it anyway. So, how did ESNI obtain an encryption key to use for encrypting the SNI data in the first client hello handshake packet? Believe it or not, ESNI gets that key from DNS. When an ESNI-aware browser looks up a domain's IP, it also asks for the server's ESNI public key for the same domain in an ESNI DNS text record. So now the web client is able to use the targeted server's IP address to establish the connection and its DNS published public key to encrypt the ESNI data for inclusion in its initial ClientHello packet. Okay, well, there are several problems here. The first is that DNS is an unencrypted and unauthenticated protocol, which means that anyone eavesdropping on a client's DNS queries will see them looking up domains and obtaining IP addresses and now ESNI public keys for specific domains. Okay, but wait. We do have DNS over TLS, aka DOT, and DNS over HTTPS, known as DOH. So believe it or not, the use of some form of DNS connection authentication and encryption is now required as part of this messy solution. I did warn everyone that we had a kludge coming, and it gets worse. The unanswered question is, in a multi-homed environment where the incoming server specifying SNI is encrypted, how does the receiving server know under which server's DNS published public key the SNI was encrypted? The answer is that a single public key is now shared among all domains that share a common IP address. So a front-end ESNI decryptor first receives any incoming TLS ClientHello message containing an ESNI extension. That server knows the private key that's associated with any of the domains sharing that single IP. So it decrypts the incoming ESNI data, determines the SNI target for the connection, and returns that server's certificate. Wow. Okay. The problem here, aside from this being a growing mess, which it is that the SNI data is the only part of a connection's metadata exchange that's encrypted. In other words, it's the SNI didn't used to be encrypted. It was in plain text. So everyone looking at those ClientHello packets go by knew who the user was asking to connect to. So that was encrypted, creating ESNI, and then also necessitating the mess of having a DNS publish the public key, which was being used to encrypt the SNI data, which would then be decrypted by its recipient across however many domains were sharing that IP. On the other hand, only the SNI data of the entire ClientHello is encrypted. So it turns out this leaves plenty of useful to snoopers connection metadata unencrypted. It's not worth getting into the details because it turns out that all of this mess will have been transient. But to give everyone a feel for it, here is a snippet of what Cloudflare wrote about ESNI, this proposal, nearly 3 years ago. Cloudflare wrote, while ESNI took a significant step forward, it falls short of our goal of achieving full handshake encryption. Apart from being incomplete, it only protects SNI. It is vulnerable to a handful of sophisticated attacks, which, while hard to pull off, point to theoretical weaknesses in the protocol's design that need to be addressed. ESNI was deployed by Cloudflare and enabled by Firefox on an opt-in basis in 2018, an experience that laid bare some of the challenges with relying on DNS for key distribution. Cloudflare rotates its ESNI key every hour in order to minimize the collateral damage in case a key ever gets compromised. DNS artifacts are sometimes cached for much longer, the result of which is that there is a decent chance of a client having a stale public key. While Cloudflare's ESNI service tolerates this to a degree, every key must eventually expire. The question that the ESNI protocol left open is how the client should proceed if decryption fails and it can't access the current public key via DNS or otherwise. Okay, in other words, this is just an incredible mess. Getting the privacy that we want is really difficult. So the architects of all this set about coming up with a means for encrypting the entire ClientHello packet, leaving nothing of it in plain text for any snooper to obtain. And to their credit, they also solved the problem that snippet there at the end mentioned with stale DNS data messing everything up. So, how do we get to the title of today's podcast, which is Encrypting ClientHello? And it's arguably even messier. The only thing I can imagine that these people really wanted to solve, the only thing I can imagine is that these people really wanted to solve this problem from where we stand today, even though there is no really good solution. But stepping back from the details, which is what we're about to step into further, I can appreciate that eventually, once all of this has been established, like sometime in the future, and is in place, and is just the way things are done, a major step forward will have been taken toward improving the privacy and security of the internet. It's just that things had been, as I said at the top of the show, so much simpler and more straightforward until we really required this level of privacy enforcement. Okay, in any event, ESNI, with all the time and effort that went into it, will eventually be fully replaced by its successor, ECH, Encrypted ClientHello. This would close the gap left open, and it will close the gap left open by ESNI. It will protect all privacy-sensitive handshake parameters. Okay? So how does it operate? Similar to ESNI, ECH initially uses a public key distributed by DNS because there's just no other practical way to distribute the key. And it must be obtained using DOH, DNS over HTTPS, for the sake of preventing eavesdropping on that information and also security. So we still have the DNS is in the loop problem. This key is used during the client's initial server outreach. That is the public key obtained over DNS, used during the client's initial server outreach. But DCH, this successor protocol, has added some clever improvements and fallbacks when the DNS key distribution fails, which make the resulting protocol more robust in the face of DNS cache inconsistencies. Where an ESNI server aborts the connection if the decryption of the SNI data should fail, an ECH server attempts to complete the handshake by dynamically supplying the client with a public key it can use to retry the connection. Like I said, nothing is simple anymore. Okay, so if ECH encrypts the entire ClientHello packet, if its decryption fails, how can it possibly complete the handshake if it's unable to decrypt the ClientHello? So now we enter the mega kludge. The ECH protocol actually uses nested ClientHello messages. Unfortunately, moving it into the future, we're not going to have anything being simple here. We're going to have what they call ClientHello outer, which is sent unencrypted in the clear, and now ClientHello inner, which is encrypted and sent as an extension of the ClientHello outer. That is, that's the way ClientHello inner is attached. TLS handshakes have a flexible extension mechanism, and so you're able to and that's what SNI is. It's an extension data field added to the hello. Well, so now this encrypted inner ClientHello will be an extension added to the unencrypted outer ClientHello. If the decryption of the inner ClientHello succeeds, the server will proceed by using the inner ClientHello data. Otherwise, it will use the unencrypted outer ClientHello. Okay, but hold on. The outer ClientHello was never encrypted, so we can't really use it for anything, right? Unfortunately, that's true. The outer ClientHello, while also a valid ClientHello message, is not used for the intended connection. Instead, the handshake is completed by what's being called the ECH service provider, which is that I talked about it before in the ESNI context. That is, it's something that answers all of the incoming connections. It's the common server that initially fields, all attempts to connect at that IP. Using the unencrypted outer ClientHello, this ECH service provider signals to the client that its intended destination could not be reached due to a decryption failure. Remember, because if the encryption had succeeded, then the connection would have been made. In other words, the initial handshake's inner ClientHello could not be successfully decrypted. And while sending that news back to the client, it also sends back the correct ECH public key. That is, it overrides the DNS which the client first attempted. So if that fails, then this ECH service provider sends back the correct ECH public key, which the client can then use to retry the entire handshake. In so doing, it's able to correct the client's copy of the connection's wrong ECH public key, which it would have received from DNS. Or, if Cloudflare is still rotating these public keys every hour, then the client has an ongoing relationship with some server that Cloudflare is hosting, well, that key is going to get stale. So at some point, a connection will fail. In the failure, the updated public key is sent back to the client, and it then uses that in order to encrypt the inner ClientHello packet and is able to resume connections until once again that key expires. So there is a great deal of understandable concern over what breakage is going to occur with these changes. ECH attempts, as I said, to hide the inner ClientHello by defining a new TLS handshake extension to contain it. The hope is that random filtering middle boxes along the way, placed who knows where on the internet, will just overlook any unknown new TLS extension types. but no one knows for sure yet. The people who initially began experimenting when TLS 1.3 was created were quite surprised that so many connections were failing. It turned out that this was due to traffic filtering and analyzing middle boxes which were crashing when they encountered the original unexpected TLS version 1.3 packets. It was only after the 1.3 designers deliberately redesigned their shiny new protocol to much more closely resemble the existing 1.2 that they were then able to get their packets through, basically creating a look-alike version 1.3 protocol that was finally able to succeed on the internet. So again, who knows what's going to happen once TLS ClientHellos incorporate a nested and encrypted inner ClientHello. Hopefully all will go well. But in any event, as I started out noting, this is all actually happening. Now, the announcements are probably more interesting. Again, Chrome has been testing ECH for months and is now enabling it by default in Chrome 1.17, with Firefox to follow closely behind. And as of last Friday, Cloudflare launched their server-side support for ECH for all of their customers. So it's happening. I don't mean to, come off sounding too pessimistic about all this. I'm glad that this work has been done and that the world is moving forward. Unfortunately, it does mean that, the way that all of this stuff once worked, which was so clear and clean and simple and elegant, is going away. It also wasn't fully secure or private.
Right.
And it turns out that creating true privacy for a massive global public network is not an easy thing to do.
Well, as you said at the beginning, none of this was designed to be secure and private. And
right.
so it's
there
all
was
tacked on after the fact.
Yep.
Yeah.
Yep.
Yeah.
And now this is not a tack. This is a box of nails.
Let's hammer this in. Steve Gibson always see, that wasn't so hard. Aren't you glad you listened? Your brain is now about 1/8 of an inch bigger, full of all that great ECH information. Thank you, Mr. Steve Gibson. You can find Steve at his website, grc.com. Now, there's several reasons you might want to go there. Of course, number one, SpinRite, the world's finest mass storage maintenance and recovery utility. 6.0 is the current version, but 6.1, it's got to be just like any minute now.
I'm going to get back to it really soon.
So close. You will get it automatically, by the way, if you buy SpinRite today. So that's worth going there for. grc.com. There's lots of other stuff, including his forums. There's a feedback form if you have feedback for the show at grc.com/feedback. There's also copies of the show. Steve has the usual 64 kilobit audio, but he also has two unique forms. One is a 16 kilobit audio for the bandwidth impaired. It's a little scratchy, but it works. It saves you some bits. There's also the transcripts. That's probably the smallest version. Elaine Ferris writes those from the 16 kilobit version. And you can find that all at grc.com if you want to read along while you listen or use it for search, etc., etc., etc. We have 64 kilobit audio at our website, but we also have video in case you want to see Steve's smiling visage at twit.tv/SN. Frankly, if you're in a hurry, the best way to participate in the show is to watch us do it live every Tuesday about 1:30 Pacific, 4:30 Eastern, 20:30 UTC. The live audio and video streams are at live.twit.tv. And one of the advantages of watching live is you can chat at us live if you wish. irc.twit.tv is open to all. You can use your browser for that. And of course, if you're a Club Twit member, and I do hope you are, you can use the Club Twit Discord. That is one of the main benefits of Club Twit. Actually, I guess originally when we created the club, the benefit of that $7 subscription was you're giving us money. We don't have to play advertisements for you. So Club Twit members don't get advertising. They don't even get this mention. But they also get access to the Discord for great conversations. If you're a sci-fi fan, John Scalzi joins Aunt Pruitt in conversation this Thursday. And John's latest book is the subject of our Stacy's Book Club. That's coming up next month. We've got an escape room coming up. All the TWiT hosts are going to get together in the studio. Jason, Ant, Micah, and I will all be kind of trying to solve this escape room. You can watch. The mirth and merriment will be fast and furious with that, I'm sure. We do a lot of club events. We also do special shows in the club, like Hands on Macintosh with Micah Sargent, Hands on Windows with Paul Thurrott, the Untitled Linux Show with Jonathan Bennett, the Giz Fizz with Dick DiBartolo, Scott Wilkinson's Home Theater Geeks. I can go on. There's a lot of benefits because we know $7, it's a lot to ask. We want to make sure you get your money's worth. But one thing that isn't on the spec sheet, but really is the truth, is you'll get that warm and fuzzy feeling knowing you're keeping TWiT alive. You're supporting the continued production of our shows. And increasingly, it's the club that's doing that. So please, if you're not a member, twit.tv/club-twit. And I thank you from the bottom of my heart. Let's see. The website, twit.tv/SN. That's where you'll get the podcast. There's a YouTube channel dedicated to security now. You know, honestly, what we really would like you to do is subscribe in your favorite podcast player. That way you get it automatically. You can listen anytime you want. Just search for Security Now, or better yet, search for TWiT. Press subscribe. It doesn't cost you anything to subscribe, so subscribe to all of them. And that way you'll have a never-ending supply of fascinating, informative technology information on your device. Steve, have a great week. Thank you so much.
Once again, I will see you next week for the announcement of the release of ValiDrive back to SpinRite 6.1 and episode 943.
Can't wait. See you next time.
Bye.
Come join us on This Week in Enterprise Tech. Expert co-host and I talk about the enterprise world, and we're joined by industry professionals and trailblazers like CEOs, CIOs, CTOs, CISOs, every acronym role, plus IT pros and marketeers. And we talk about technology, software plus services, security, you name it, everything under the sun. And you know what? I learn something each and every week, and I bet you will too. So definitely join us. And of course, check out the twit.tv website and click on This Week in Enterprise Tech to subscribe today.
Security.